Hello dear students, welcome back to physics online session. So today we will be discussing about electric cell. So in case of that current electricity, we are going to understand about that cell. So today onwards we will be speaking about that cells. So in case of the deal with the cell, first we may come to know about what you mean by that cell here. And in case of cell, I need to understand what you mean by EMF, what is the terminal potential difference, and what is that internal resistance. So these are all the basic terms I need to understand in case of cell. So today our discussion will be start with cell here. So I think you heard about that name, means usually you are going to use in day-to-day life. So for example, in case of that TV remote, you are going to use cell, or in case of that wall clock, you are going to use that cell. So then what you mean by that cell here? So cell is a device which provides necessary potential difference here. So what do you mean by cell here? Cell is a device which provides necessary potential difference and it helps to maintain that constant amount of current here. So look at here. So in case of that cell, so cell is a device. It is a device. It is a device which provides necessary potential difference, which provides necessary potential difference, and it helps to flow constant current. So look at here, because of the differ in the potential, current will get flow here, so that we can call it as cell. So in case of that cell, it consists of two terminals here. So it consists two terminals. So what are those? So in that cell you may observe that one is negative and another one is positive here. One is positive terminal, another one is negative terminal. So in case of that cell, we can take that positive terminal as well as negative terminal here. So in case of that cell, for example, you can take that electrolyte of a cell. So in chemistry you heard that name. For example, here I will take one electrolyte solution here. So this is electrolyte solution here. Now I will take that two electrodes here. So for example, this is one electrode and this is another electrode. It consists of two electrode, and from this electrode I will provide that external resistance connection. For example, I will connect here. For example, this is resistance R I will take. So for example, if it is electrolyte solution, means on that one electrode, suppose positive ions will get accumulate, means on that other negative ion should get accumulate here. So did you get my point? So on that one electrode, so this is electrode and this one is electrolyte solution, we can call. So on that one electrode, positive ions will get stored and on the other negative ions will get stored. So we'll understand that mechanism of the battery here. So for example, these electrons are moving from that negative to positive. So what is the direction of the current? Current direction is from positive to negative. So this is the direction of current and electrons are moving opposite to the direction of the current. We can take it here. So these things already we discussed. So here that electrons are moving from that one point to another point. It will reach here and these electrons again will goes to that negative terminal of the electrode. So it completes one circuit here. So when electrons are moving from that one point to another point, so right, so in case of moving that electron from that one point to another point, it will reach here. After that, so this electron will get moved from that positive terminal to again negative terminal of the electrode. So that completes one circuit you can call. So in case of that cell, I said one is positive terminal and another one is negative terminal. There exists a potential difference between these 2 points because of the differ in the potential. So then what happens here? So you are getting current in the circuit here. So current will get flow through the external resistance here. So in case of this electric cell, we are going to understand about, so we are going to understand about that EMF here. So look at here, we need to understand about EMF. What is the long form of EMF? Electromotive force. What is the long form of EMF here? Electromotive force. So what's the mean of that EMF or electromotive force here? So look at here, in order to understand about that EMF or electromotive force, so I can consider that, for example, so this is one battery I can take, or you can take that as a cell, you may call by the name cell or battery, whatever. So in case of this battery, current is flowing from that one point to another point here. So for example, this is point P you can take, and this one is point Q you can take. So there exists a potential difference between the terminals of the cell here. So potential difference between the terminals of the cell when no current is flowing through the circuit. For example, this circuit is not complete here. If the circuit is not complete, means current will not flow from that P to Q here. So that we can call it as EMF or electromotive force. So how will you define that EMF or electromotive force here? Potential difference across the terminals of the cell when no current is flows through the circuit. So that no current flows means, so that is nothing but open circuit. So for example, in simple way I can say, for example, if you go to the shop and you have to purchase one cell here, so that cell you are not going to use here, so that cell is not using means, so that we can call it as EMF. So potential difference across the terminals of the cell when no current is flowing here. So from the cell current is not flowing here, you are purchasing from the shop here, so that cell I can take it as EMF here. So then how will you define here? Potential difference between the terminals of a cell when no current is flow through it, so that we can call it as EMF. So or in other sense I can call this EMF or electromotive force means, so amount of work done to bring unit positive charge from one terminal to another terminal, also we can call it as EMF here. So what is that EMF here? Amount of work done to bring unit positive charge from one terminal to other terminal. So this is also we can call it as EMF, we can call it. So in case of that EMF, I said potential difference between the terminals of a cell when no current is flows through it. So if the current is not flowing means, so this is nothing but open circuit. So I can call this one as open circuit cell. So we can call that EMF also as open circuit cell we can call. For example, this cell if you are going to using now, for example, the same cell if you put in the wall clock or if you put it in the remote control, so then what happens here? Current is starts flowing from that cell to the circuit here. So from that cell to the circuit, whatever, so you can take this is remote or whatever the device you can take. So current is starts flowing from that one point to another point. So in the circuit current is flowing here, so that we can call it by that another name, so that is terminal potential difference. So we need to understand one more term here, so that is terminal potential difference here. So look at here, terminal potential difference. So what is the terminal potential difference here? So terminal potential difference gives the same meaning. For example, potential difference between the terminals of a cell when current is starts flows through the cell here. Current must start flow means, so that is nothing but a closed circuit here. Current is flowing throughout the circuit. So if the current is flowing throughout the circuit means, so that potential I can call it as the terminal potential difference. In the similar way you can understand. For example, if you go to the shop, if you purchase one cell here, so if you purchase one cell means, so that cell is example for EMF means you are not going to use that cell. Now that cell if you are put it into the wall clock or if you are going to place in the remote control, so then what happens here? So then that current is starts flowing from that cell to the circuit. When the current is flowing from the cell means, so that we can call it as terminal potential difference here. What is that terminal potential difference then? Potential difference between the terminals of the cell, potential difference between the terminals of a cell when current is flows through the circuit, flows through the circuit. So that we can call it as terminal potential difference. Or current is flows through the circuit means, so that is closed circuit, so that we can call it as closed circuit. So open circuit cell you can take it as EMF, whereas closed circuit cell you can take it as terminal potential difference. So now we are going to understand that one more term here, so that is internal resistance of a cell. So now we will understand about that internal resistance. So we heard the name resistance. What's that new term? Internal resistance. That word refers, internal means inside here. So look at here. So I said this is electrolyte solution. So this electrolyte solution only will make certain kind of opposition for the flow of current. So did you get my point? So here electrons are moving from that one plate to another plate like this. So here that electron will come. Now again that electron will move from that one plate to another plate. While moving it from that one plate to another plate, so here what happens here? Electrolyte solution will make certain kind of opposition. So that opposition offered by the electrolyte of a cell, so that opposition we can call it as internal resistance. So how will you define that internal resistance here? Opposition offered by the electrolyte of a cell. So whatever the electrolytic solution you are going to consider, that electrolytic solution will make certain kind of opposition. So that opposition I will name it as internal resistance. In another way I can say that cell itself, it will make certain kind of opposition for the flow of current. So remember here, in case of that cell, so it consists certain kind of chemical energy. So that chemical energy will converts into a electrical energy, right? So while converting from that chemical energy into a electrical energy, so we can consider that, so whatever the electrolytic solutions you are going to consider, that electrolytic solution will make certain kind of opposition for the flow of current. So that kind of opposition we can call it as internal resistance. So then how will you define that internal resistance here? Opposition offered by electrolyte of a cell is known as internal resistance. We can call that as internal resistance, or we can say by that another definition. So that one is the cell itself make, so the cell itself make certain kind of opposition for the flow of current. So that we can call it as internal resistance. So in chemistry also we will understand about that electrolyte cell. So just I am using the terms. So what you mean by that EMF, what is the terminal potential difference, what is that internal resistance, and what is that cell here. Now we will get that equations for that relation between EMF, terminal potential difference, and internal resistance here. So that internal resistance is represented by the symbol smaller. So what is that symbolical representation of the internal resistance here? So that internal resistance is represented by the symbol smaller here, whereas EMF is represented by the symbol E here, whereas terminal potential difference is represented by the symbol V. So terminal potential difference also we can call simply by the potential difference also. So look at here, EMF is nothing but open circuit cell, means current is not flowing through the circuit. So current is flowing through the circuit means, so that is terminal potential difference. So just you may remember that if you purchase the cell, if that cell you are not using, so that is EMF. If you use that cell, current will starts flow from that cell to the circuit, so then it becomes terminal potential difference. Now we will understand what is that mathematical relation between EMF, terminal potential difference, external resistance and as well as internal resistance. So by the mathematical approach I can conclude what is the relation between EMF, terminal potential difference, external resistance and as well as internal resistance. So one more important term is there. So about that internal resistance, what is that internal resistance here? That cell itself, it makes certain kind of opposition for the flow of current. So that resistance will call by the name internal resistance. So now we'll look at that relation between current. So we'll find that relation between current, internal resistance, external resistance and EMF and terminal potential difference. I want to find out that connecting formula for these terms. So for that purpose, first let me take one cell or battery you can consider. It consists of positive terminal, another one is negative terminal. So this battery is connected to one external circuit. So I can take one resistance or bulb, whatever you can take. So I provide that external resistance connection. So look at here. So EMF of the cell, I can take it as E here. So this cell will make certain kind of opposition. So look at here. So internal resistance is present between the cell here. So look at here, internal resistance is present between the cell, but it is impractical to draw that internal resistance between the cells. So for that purpose, just I will take that nearby the cell. If that resistance symbol is present nearby the cell means, so that you can take it as internal resistance. This is about external resistance here. Now I have to find out that relation between current, internal resistance, external resistance and EMF of the cell. So from the battery, so certain amount of current starts flowing through the resistance here. So consider a battery or cell. Consider a cell of EMF E. So what is the EMF of the cell here? EMF E, and having internal resistance and having internal resistance. So internal resistance is smaller. Internal resistance is represented by the symbol smaller, having internal resistance, and it is connected to external resistance. So it is connected to external resistance. So that external resistance is represented by the symbol capital R. Now by the definition of EMF, so what's the definition I said? So the potential difference between the terminals of the cell when no current is flow from that one point to another point, or by another name I said. So I said that, so in case of that EMF, so work done to bring unit positive charge from that one point to another point here. So let me choose that 2 point here. So positive terminal I can take it as point A and negative terminal I can take it as point B here. So look at here, in order to complete the circuit, so electron move from that positive terminal go to negative terminal, means from that point A, work done to bring unit positive charge. So first I can take it that work done to bring unit positive charge from that A to B here. So that is EMF. And another thing, work done to bring that unit positive charge from that B to A against the internal resistance. From A to B, what kind of resistance is there? So in order to bring unit positive charge from A to B, external resistance is there, whereas in order to bring it from B to A, what kind of resistance is present between the cells? So that is internal resistance. So I can take that EMF is equal to work done to bring unit positive charge from A to B plus work done to bring unit positive charge from B to A. Look at here, from A to B means, so that is against the external resistance, from B to A means against the internal resistance. So that we can call. So EMF is equal to work done to bring unit positive charge from A to B. So that is potential V I can take, against the external resistance is V, against the internal resistance I can take it as V dash. So from the definition of EMF I can write that E is equal to V plus of V dash. So where V refers to potential difference against the external resistance, V dash means against the internal resistance I can take. So where from Ohm's law V is equal to what? I into R against the external resistance. V dash is equal to what? I into small r against the internal resistance. So I will substitute these value in equation 1. So just look at here. So put equation 2 value in equation 1 here. So if I do like so, so look at here, E is equal to I into R plus of I into small r. So shall I take that I as a common here? R plus of R, it is equal to E. I can rearrange. So I is equal to E divided by, so this term I will take to left side. So I is equal to E divided by R plus of R. So this is the relation between current, EMF, external resistance and as well as internal resistance. I got that one expression here. So here I refers to what? Current here. I refers to current, whereas E refers to EMF and R refers to external resistance, whereas small r refers to internal resistance. I got that relation between I, E, R and small r here, where small r refers to internal resistance. So now I can take that equation 1. So I will rearrange that equation 1. Equation 1 can rearrange as so where V is equal to, shall I write it as a, so what can I rewrite here? So V is equal to E minus of V dash. V is equal to E minus of V dash here. So look at here, V is equal to what? E minus of V dash. So V is equal to E minus of V dash is nothing but what? I into R. So look at here, V is equal to E minus of I into R. So where V refers to what? Terminal potential difference. What that V represents here? V represents terminal potential difference, whereas E represents that EMF. Relation between terminal potential difference and EMF, and I refers to current, small r refers to internal resistance. So here, so where V represents that terminal potential difference, where E represents that EMF, where I into R represents that potential difference across internal resistance. So potential difference across internal resistance. So now here that terminal potential difference and EMF, which value will be greater I can consider. For example, I will take one cell here. So this is about discharging cell. What kind of cell it is? So there are two types of cell. So in next class I will speak about those types of cells. So just for time being, so this is one discharging cell I can consider. So on that cell, so they mention that 1.5 volts. So if you are not using that cell means, so that 1.5 volt is act as EMF. Why? Because that is open circuit cell. So for example, if this is one cell, so how to consider this cell? On that cell they mention 1.5 volt means, so that is EMF value. So its value, EMF value is 1.5 volt here, right? Next one, what about its terminal potential difference? I need to find out here. So for example, V is equal to E minus of I into R. So where V represents the terminal potential difference. So EMF is 1.5 volt. So minus of, so that cell means, if you are using that cell means, of course it consists of internal resistance here. For example, if that IR product is, you may get it as 0.1 volt. So then what about that terminal potential difference value? 1.4 volt. So look at here, EMF value is how much? 1.5 volt. Terminal potential difference value is how much? 1.4 volt. It means that, so in case of discharging cell, EMF value is always greater than the terminal potential difference. Which value will be greater here? EMF value is always greater, or in other sense I can say, terminal potential difference value is not greater than the EMF of the cell in case of discharging cell. In case of discharging cell, so what about the discharging cell here? So discharging cell means current is drawn from that cell to the circuit. So current is flowing from that cell to the circuit. So that type of cell we can consider as discharging cell. In case of discharging cell, EMF of the discharging cell is greater than the terminal potential difference. So this is the relation between current, EMF, external and internal resistance. This is the relation between terminal potential difference and EMF of the cell. Now let me consider one more term, so that is internal resistance. So have to find the value of the internal resistance. So look at here, in order to get the value of internal resistance, okay, so for example I will use this equation, minus I into R, I will take it into left side. It is equal to E minus of V. So where R is nothing but what? Internal resistance. E minus of V divided by R. So this is the expression for internal resistance. So it not get stop here. So where I is nothing but what? From Ohm's law, shall I write it as V by R? So look at here, R is equal to E minus of V. So wherever I is there, so just I will take it as V by R. So R will goes to numerator here. E minus of V divided by V, or shall I write this one as E by V? V by V means 1 here into R. So this is the required expression for internal resistance, or one more form I can write, E minus of V divided by V into R. So this is the required expression for that internal resistance of a cell. So hope you get that information about that cell, internal resistance, external resistance and terminal potential difference and EMF of the cell. So this is all about a cell. So in next class we will be speak about that what are the types of cells. So in case of charging cell and in case of discharging cell, for that short circuit cell. So all the things we'll discuss in next